My name is Dr. Ashraf Yasmin. So I'm going to take about the database management system. So I'm from CSC department. So the unit 2 process has been going on. The first is enhanced ER model. So the enhanced ER model, what is it? Enhanced, it's the moderate of ER model. So it is extension of traditional ER model used to represent the complex database requirements. Okay. So the enhanced ER model, along with other improvements, new concepts that were added here. So what are the new concepts here is generalization, specialization, and aggregation. So what is generalization? Generalization is a bottom-up approach, okay, in which two-layer entities combine to form a higher level entity. Two-level entity form a higher level entity. That is a generalization. What is a specialization? The specialization is opposite to generalization. That is top-down approaches. So it is one higher level which is connected to two entity, two broken down into a two-level entities. Okay. So the diagram shows the generalization and specialization. So generalization, the account of a customer which consists, it can be a saving account or current account. It is generalization. Okay, that saving, current account types entities can be generalized, and entity with the name account can be created which covers both. Okay, what is a specialization is if it takes a student, it can be a old student, ex-student, or currently studying student. That is specialized. Okay, the specialization is opposite to generalization. It is top-down approach in which one higher level entity can be split into a two. Okay, so two-level entity. Next is the enhanced ER model. Having another session is aggregation. So the aggregation is the process when relation between two entities is treated as a single entity. The aggregation process is when relation between two entities is treated as a single entity. Okay, so for example, if a center is there, this is offering some courses, okay, and the visitors were entered into inquiry. Okay, new visitors inquiry. Okay, so this diagram, this shows the relationship between the center which has the courses together. It's acting an entity which is relationship with the another entity. Okay, visitors, okay, inquire about the visitors. Okay, visitors is inquiring about which center which providing a courses and analyzing it. Okay, so this is a special one is aggregation. Okay, the next is functional dependencies in DBMS. The functional dependency is tribal function dependencies, non-tribal function dependencies. So function dependent occur in one attribute uniquely determined the another attribute. Okay. So tribal, which means X shows Y. Okay. Dependency. The dependent is always subset of the determinant. Okay. X is a subset of Y. Okay, and Y is the subset of X. Then it is called tribal function. Okay. So we should look at this X, which gives us Y. That means Y is a subset of X. Okay. What is the second thing is non-trivial function dependency. So non-trivial function dependency, it is X, which is shows Y, which is connected to Y. Y, it is not a subset of X. Okay, that is a non-trivial function. It is not a, that means the non-trivial function dependency, the dependent is strictly not a subset of determinant. Okay, X but belongs to Y. Okay, X which belongs to Y, but Y it's not a subset of X. Okay, that is a non-trivial. For example, ID and name. Okay, we can mention the ID. Okay, belongs to name. Okay, if ID connected, it shows the name. Okay, name it connector with the date of birth. It may be subset or maybe may not be. So this is the non-trivial function dependency. Okay. So functional dependencies as another semi-non-trivial function dependencies, multi-valued functional dependencies, transitive functional dependencies. So semi-non-trivial function dependencies. So occurs when part of the dependent attributes, it include in the determinant left-hand side, but not all of it. Okay, so left-hand side it shows multi-valued functional dependency entities of a dependent set are not dependent of each other. Okay, A, which belongs to B and C, is that exists no functional dependency between B and C. Okay, so it's multi-valued. Next, what is transitive? Transitive function dependency dependent indirectly dependent on indeterminate indirectly. Okay, so not directly dependent. So A belongs to B and B belongs to C. Then according to the axioms, so A automatically belongs to C. Okay, this is the transitive function. Okay, but they're not directly, indirectly they're connected to the functionalities. Okay, so next is Lucillus decomposition in DBM. The another concept is, what is Lucillus? That is, the decomposition is a process of decomposing relation, the total multiple relation, in such a way that it preserves the information contained in the original format. Okay, that means joining the decomposed tables give back to the original one. For example, there is no an extra or missing rows are created. Okay, so if A, B, C, these are the rows which consist the values, we can be decomposed into AC and BC. Okay, so AC have the values, C also having the values, B, C. So look at the B having the values splitted, we decompose splitting, okay, and C having the values. So again what we'll do, we are combined, okay, Lucillus combination, make into a combination of ABC values and finally give the outage of table. So in that outage table, the original, which is the same, looks like a decomposed one. Okay, decomposed and split. Okay, so look at this, the first table which have the same values, which is the after the decomposition of the values. Okay, so this is the Lucillus. So when we decompose the table, then any loss of values will be done. Okay, so that is a decompose. Normalization rules in DBMS. The first normalization form. So it ensures that structure of database table organized in a way that and make easier to manage and query. Okay, in relation first normal form is very attribute. Every attribute relation single value attribute or it does not contain any composite or multi-value attribute. For example, this is the course table. Okay, ID, name and courses. Okay, ID, name and course is the course table. And another course table which is ID, name, courses. Okay, the single values. So, okay, not a multiple values in the single values. Okay, so the A concept, that means the first normally ensure the structure of database table organ that make manage and query. Okay, so when the course table courses that have this, the two tables have some identification. Okay, the course table which consists VA consists C1 and C2. Okay, and E consists C3 courses. Okay, but in another table we can split and A having C1. Okay, A another C2. The selected, that means A student selected the C1 course and another A1 same A1 selected the courses C2. Okay, so look at the difference. So that is a normalization form. Okay, what is a normalization? 2. Okay, second normalization based on concept fully functional dependencies. It is way to organize a database table so that it reduce redundancy and ensure data consistency. Okay, the table must already be in the first normal form. Then it come to the second normal form, and there is no partial dependency in the table. So look at this course table, student course table, and course table. The course table, the student have consist of student number, course number and course fees. Okay, this is the course table. So the output can be a student table and course table. So student table show that the student number we can relate it with the course fees, course number. Okay, the student number we can relate it with the course number. That is a student table. Each student, if a student 1 having a course number C1, the student number 2 having the course number C2. Okay, again the course student number having the C4. Okay, course 4 it can maybe have. So this is the data student taken course tables. Okay, the another table we can say as this is a no partial dependency, right? So the course number and course fees we can split it, the course number and course fees. So the course number C1 which fees has 1000. Okay, the course C2 have the course fees 1500 and course 4 having the value fees has 2000. So we can split the course normal file into a student course table and course table. You can split into that, but there is no any partial dependencies. This formalization is called a second normalization form. And third normalization, it satisfies the two conditions. It should be satisfied second normalization form, as well as there is no transitive dependency for non-prime attributes. So, for example, look at this, the candidate table. It can be split into two. The candidate table, the candidate number consists of candidate number, name, state, country, and age. Okay, the candidate details will be considerable. What is the output can be? The candidate table and state control. So, for example, the candidate table which consists the details, number of the candidate, name of the candidate, state of the candidate, and age of the candidate. Whereas the state table which defines the state which have the code, country code. Okay, the West Bengal which belongs to India, Haryana which belongs to India. Okay, so we can that there is no transitive dependency. Okay, transitive dependency issue. So it belongs to third normal form. So the candidate table having all the details, whereas the candidate table only we can have the details about the candidate number, name, state, and age, whereas the state table denoted the state which belongs to which country. Okay, so this is the no transitive dependency form. Okay, and next, thank you so much. And these are all we have normalization form in DBMS. We'll explain a lot with the example tables, and we're going to the overview of the second unit. Okay, thank you so much.